This question asks us to find the volume of the parallelepiped, which has vertices at A, B, C and D. As soon as we see volume, we know it's not the cross because the cross product is area. We know it's not the dot because that's a scalar quantity, which is good, but it's allows us to calculate angles, etc. And we know there's one other one, and that's the scalar triple product. So we're going to find the scalar triple product to calculate the volume. So to get a bit of an idea of what's going on, we should draw up some axes, and here once again I've put X, if you like, coming out of the page, Y where our normal X is, and Z where our normal Y is. Now once again we use the right hand rule, which lay your right hand along the X-axis with your fingers pointing out in the positive direction, curl your fingers around, and that'll tell you which direction to put the Y, and then your Z will be pointing straight up the page. So that's the X, Y, Z, that's these 4 points plotted. Now these form the vertices, which are the corners of this parallelepiped. So we can now draw in the sides. So if you like, AC and AD form two sides of the parallelogram, which forms the base. So this will be the base of my parallelepiped. So AD can be repeated over there, and AC can be repeated up there, and we have a parallelogram. And then to get some height, we go up AB. So it means I've got to draw another 4 of those. Now I can draw the top. Okay, so there's my parallelepiped. It's all faces are parallelograms. And we know to find the area of the base, it'll be AC, vector AC, cross with vector AD. And then to get the volume, we dot that with the height, and we dot that with AB. And as we know, there's only one way to calculate that. We can do that first and then do the dot product. This will be a vector, and then a vector dotted with another vector. The dot product will give us a scalar quantity. So this will be my volume, will be equal to that. Now, we haven't got vectors AB, AC and AD, but we can go through and work those out. So to work out vector AB, which as we know is a displacement vector, it'll be the position vector of point B minus the position vector of point A. Now position vector is just from the origin out to point B. Now we know B is 5, negative 3, 6, so it'll be 5i, so vector B is 5i minus 3j plus 6k minus, so there's vector B minus vector A. Vector A is 5i minus 4j plus 3k. And these are all vectors, obviously. And 5 minus 5, so that'll give us 0i minus 3 minus negative 4. So negative 3 minus negative 4, negative, negative, positive. So that'll be 4j minus 3j, which will be plus j. And then 6k minus 3k will be plus 3k. So there's my vector to go from A to B, will be 0i plus j plus 3k. So that's AB. AC will be equal to always the position of the first minus the position of the second, so it'll be vector C minus vector A. To get to vector C, we've got to go out 5i plus 1j plus 3k. So that's vector C minus vector A. Vector A is the same one as up here. 5i minus 4j plus 3k. And 5 minus 5 is 0i. Now 1j minus is a plus, so that'll be 1j plus 4j will be plus 5j. And 3k minus 3k will be plus 0k. So there's vector AC. And finally we've got AD to calculate. Vector AD would be vector D minus vector A. Vector D up here will be 3i minus 4j plus 3k. And from that we've got to subtract our vector A again. So that'll be 5i minus 4j plus 3k. 3 minus 5 will be negative 2i. Minus 4 minus 4, so minus 4 plus 4 will be plus 0j. And then 3k minus 3k will be 0k. So we've now got our three displacement vectors. We've got AB, we've got that vector there. We've got vector AC, and we've got vector AD, which is that one there. So the volume will be equal to the product, the scalar triple product. Now, we've learned how to calculate this using the determinant of a 3 by 3. We write down AB first. So we've got 0, 1 and 3. We've got AC is equal to 0, 5 and 0. And we've got AD as negative 2, 0 and 0. We put a plus, minus and a plus. So that'll be equal to 0 outside of 5, 0, 0, 0, minus 1, 0, 0, negative 2, 0, plus 3, outside of 0, 5, negative 2, 0, equals. Alright, we've got a 0 there, so it doesn't matter what this works out to be. So that'll be just equal to 0, because we've got 0 there and 0 there, and we've got 0 there, so we're going to get 0 there. Minus 1, inside of, once again, 0 minus 0, so that's going to be equal to 0. And then we've got 3 outside of 0 minus negative 10. So it's always that diagonal minus that diagonal, so minus negative 10. So we've got 0 minus 0 is 0, and then we've got 3 times 0 minus negative 10 is 0 plus 10, so 3 times 10 is 30. So 30 units cubed, cubic units, would be the volume of that parallelepiped. So scalar triple product is used, the answer is a scalar, and it is used to calculate volume of a parallelepiped. Don't forget, if we've just got the points in three-dimensional space, we've got to actually, they allow us to work out the position vectors of those points, but then to get the vectors, we've got to get the displacement vectors, and it's always the position vector of the second one minus the position vector of the first one.